Sir, good morning, sir.
Hello, sir. Good morning, sir.
Shall we start, sir?
Sure, we can start, sir.
I just introduce and.
Yeah, sure.
Sir, could you please on your video, sir?
Okay. Sir,
yeah. So very good morning to everyone. Good morning to Balasubramanian, sir.
Good morning, sir.
Yeah, so it's my privilege to introduce Dr. Balasubramanian. So a renowned civil engineer. Completed his BE in civil engineering in 1981 and ME in structural engineering in 1983 from College of Engineering, Guindy, Chennai. He took his PhD degree from Annamalai University. He served as Deputy Director for Structural Engineering Research Center, CSIR ACRC, Chennai. He also served as Senior Deputy General Manager R&D with Consolidated Construction Consortium Limited, CCCL famously known as. So at present, he is the Managing Director of High-Tech Concrete Solutions Chennai Private Limited, Chennai, an NABL accredited laboratory. He is also heads an IIT Madras incubated company, Concrete Quality Concepts Private Limited, along with Dr. Manu Santanam, Professor of IIT Madras. His areas of research includes concrete technology, non-destructive testing of RC structures, and repair and rehabilitation of RC structures. He is a renowned structural engineering. So he renders service to the civil engineering fraternity. So in the form of training and mentoring. He has published over 150 papers and 1,500 technical reports in refereed journals and conferences. He has filed 2 patents. He is also the Vice President of International Center for Fiber Reinforced Concrete Composites. He was a member of Board of Studies of Anna University and presently a syllabus committee member. He has served as a member in many committees of Bureau of Indian Standards. So we are delighted to have you on board, sir.
Thank you,
sir. It's an opportunity for all the participants to listen to you and share your experiences. I welcome you, sir. So I hand over the session to you to take up the lectures.
So this is comprising, Mr. Yuvraj was telling that it's comprising of faculty and students, and also from somebody from somebody from the industry also, right? Sir?
Yes, sir. Yes, sir. Practicing engineers, and it's a FDP, so faculty members. And we have opened for even research scholars and students also. Very few students are there, around 50 to 60 students.
Okay, sir. Okay.
Thank you.
Thank you very much, sir. Good morning. I would like to thank Professor Ishwar Reddy and Dr. Yuvraj for giving me this opportunity to speak to you. And today, what I'm going to speak to you is on the very practical aspects of the concrete NDT practices and the case studies. My approach would be basically to tell the faculty to approach any problem from a consultant perspective. You're all very strong in teaching, and I'm now for the past 10 years I'm more in the industry. So my talk will be more oriented towards solving industry issues from a practical consultant's perspective. I mean, this is what I wanted to tell as an introduction, and I would straight away go into the thing. And I've been doing NDT for the past about almost 35 years. So I would like to tell all the positive and the limitations also in the various NDT methods. So what are the various investigation methods? So the non-destructive test, we have intrusive test, and we have load test. These are the 3 things, because IS 456 says when there is an issue, like you do a non-destructive test, then do a load test, and finally that fails, do a core test, that fails, and do a load test. And even the load test fails, do one more time, and then finally everything is not satisfying, then you demolish. Straight away they are not telling you go and demolish a structure. So what are the various non-destructive tests that are commonly adopted? I might have missed one or two, but these are the common non-destructive tests that we are using in the construction industry. One is the rebound hammer test, ultrasonic pulse velocity test, then the core drilling test to evaluate the equivalent cube compressive strength of concrete, then the carbonation test, half-cell potential test, and even the resistivity test you can include, then the evaluation of chlorides and pH through concrete powder samples, and then the profoscope survey for identifying cover and rebars. And some of the methods that are not being very widespread used are the core trepanning method for loss and pre-stress. Generally, we have a lot of bridges where the pre-stress girders are there, and these bridges have been constructed in the 80s. And now we go there for doing condition assessment, and that time this core trepanning method will be very useful. And organizations like SCRC, they have a fairly good knowledge about this core trepanning method, and other places maybe slowly it is coming up. The other one is the flat jack technique for masonry structures. Again, very limited knowledge and usage. Again, SCRC has certain, they've been doing work in this area for more than 15 years or 20 years. And then now IIT Madras also does a lot of work on the flat jack technique, because we are having a lot of masonry structures, monumental structures, where rehabilitation is required. And to do the rehabilitation, then we need to understand the stress levels and all that. And for that, these flat jack techniques are being used. So these are the various non-destructive methods. And the non-destructive methods that are not very popular are the thermal method, radiography method, stress wave propagation method. See, the above methods are not popular because of the lack of physics knowledge on the part of the structural engineers and our reluctance to work as a team with consultants with strong physics base. For example, you have impact echo. There are so many things. There are people who are carrying it to the construction, the sites, but the interpretation is a little difficult. So unless you have a very strong physics knowledge and you have a very strong, at least have somebody in the team who has a very strong physics knowledge, then it is very difficult to interpret these methods. So that's why they have not become very popular. But times, shortly I feel people will be working more and more. So when they start working more and more in the laboratory and then take it to the field and then some correlation can be obtained, then these methods will become more popular. And right now, as of now, we are using some very rudimentary methods like rebound hammer, UPV test and all that. So first I'll tell what is the rebound hammer test. My structure of the talk is, first I'll quickly go through all the various UPV test methods, their limitations. Then I'll go into situations where these tests are being used. And finally, I'll wind it up with a case study. So rebound hammer test, most of you are aware of the rebound hammer test. It's basically a handheld equipment. It measures the surface hardness of the concrete. And it's hardness of the concrete, and rebound is measured on a graduated scale, giving a rebound number, larger the number, harder the surface. It's basically a qualitative test. Unfortunately, what is happening in our country is this rebound hammer test is being grossly misused. The reason is this rebound hammer numbers cannot predict the compressive strength very accurately. So they are having calibration graphs that have been supplied by the manufacturer, or some of the laboratories, they make some cubes, hit the hammer and try to make a correlation graph. But from my experience, it is my view that it is very, very dangerous to use a rebound hammer to predict the compressive strength of concrete, because it is always giving 1.5 times or 2 times more than the actual strength. So basically a qualitative test, because this measures near surface characteristics of the concrete, which means it measures the quality of the cover concrete. So the cover concrete is very important because it is through the cover concrete your chlorides or the carbon dioxide diffuse into the concrete, depassivate the steel. So naturally cover concrete is more important, and this rebound number may give you some idea about the quality of the cover concrete. But to predict the strength of the concrete based on the rebound number is little risky. And so it depends on the smoothness of the surface, varies with the size, shape, and the rigidity of the specimen, affected by the degree of saturation. And generally, carbonated concrete gives a very high number. So these are some of the limitations of the rebound test. And as faculty, definitely you can teach this method, but then you have to always put a rider that, predicting the compressive strength of the concrete through the rebound hammer may lead to, erroneous results. And correlation with strength, because this rebound hammer is only 70,000 rupees or 80,000 rupees. So the manufacturer always, for example, I buy from Prosec, it's a Swiss-based company, and then they give you a calibration graph based on the correlation what they have done with their cement, sand, and aggregate there. So you need to be very careful while converting, and better to use a rebound value as some kind of a quality indicator. If I get a high number, which means my cover concrete is fine. So that's all. Like, this is a calibration graph that is being given by the manufacturer. And if you look into the x-axis, this is a number, and this is the y-axis, the strength. So you hit it, and then for various angles, they are giving a strength. But that is, you have to be very careful. For example, this is an IIT Kanpur a table for a bridge, what they had done in near Kanpur. I had also visited the thing, and then this report, I took it. If you look into the core test, and the compressive strength predicted by a rebound hammer, you will always find it is rebound hammer always predicts 2 times more or 1.5 times more. But there are instances where it predicts very closer also. So, but then you need to take it with a pinch of salt. So you need to be very, very careful when you want to use a rebound hammer in predicting the compressive strength. So what is happening in our industry is, like for example, they make the columns. Within 21 days, the next slab is made. And after 28 days, the cube compressive strength results come. Sometimes the results are lower. Then the contractor is little afraid to take the course, because he knows when the cubes have failed, most of the time the course also will fail. But then the slab has already come up. So the NCs are created. NCs are created by the PMCs. NCs are created by the client engineers. And the NC has to be closed. If he takes a core, then if the core results come low, then it may lead to some strengthening, like with the micro concrete jacketing or FRP wrapping or whatever may be the thing based on the designer's thing. So that time he lands into trouble because the floor space is reduced if you are going for a micro concrete jacketing. So he brings in a agency with the rebound hammer, and they hit the rebound hammer and finally say that the strengths are fine. So the NCs are closed. So that is what I come from Chennai, where this rebound hammer test is being basically used for those things. And then another issue with the rebound, in the case of rebound hammer is when we have plastic shrinkage cracks on the deck slab, the PMCs or the client engineers are unhappy with the contractor, and the contractor does not want to own the responsibility because he has not floated the concrete and then close the plastic shrinkage cracks. So he puts the blame on the RMC guy. RMC guy does not know what to do. Like he has to get business from the contractor. So he knows the contractor has made a mistake, but then he is openly willing to admit it. So, but he knows that it is not his fault. So he wants to close the NC, brings in a guy with the rebound hammer, hits, and then says, my rebound hammer numbers are good, my concrete is good. So, I have I have not done any mistake. Then the plastic shrinkage crack has got nothing to do with the strength. It's basically you need to float the concrete. So this rebound hammer is being kind of grossly misused in the place where I come from to close these NCs, even though it is completely not relevant to do a rebound hammer test for a plastic shrinkage crack. So these are things that are happening. So you need to be very careful. I'm not telling this rebound hammer is a bad test. It's a good test, but to measure the near surface characteristics of the concrete, the quality of the cover concrete, because the quality of the cover concrete is very important, because only through the cover concrete, your chlorides or the carbon dioxide diffuse and then depassivate the steel. So next we'll go into the ultrasonic pulse velocity test. This is basically done to measure the integrity of the concrete, to check whether any voids, honeycombs, pores are there inside the concrete. So you put the transducer on one side, and then you put the receiver on the other side. The time taken by the wave to travel from this phase to this phase is measured in a equipment, maybe a pundit or any equipment. So the time taken, and the distance is known, and distance by time is velocity. If your concrete is dense, strong, perfectly all right, then the waves will travel very fast. The waves will travel very, very quickly. So the time taken will be very less. But you have voids or honeycombs inside, then it will take a little longer time. So the velocities are reduced. So this is this is a general concept. So it generally measures the homogeneity of the concrete, or measures the integrity of the concrete, or the presence of voids, cracks. Again, sometimes I find that Even the UPV, people are trying to do some calibration in the lab and then trying to create some kind of a calibration graph with UPV and rebound hammer and trying to predict the strength. So again, even an M20 concrete should show a higher velocity because it has to be properly compacted and vibrated. If you have any voids or honeycombs, whether it's an M60 grade concrete or an M30 grade concrete, obviously the velocities will be lower. So you have to understand, the limitation of these equipments in its two perspective. So just because I'm having about 5 Pandit labs doesn't mean that I can kind of use it for all the wrong purposes. And combination of rebound number and UPV may help you to identify weak areas. So that's all it gives. So what are the various methods of doing a UPV test? Direct transmission test is always better. It gives you a better confidence level. Suppose two sides are not accessible, then you can do a semi-direct transmission method where the path length will be the hypotenuse of this. Distance from this to distance of this is nothing but the hypotenuse of this triangle. And sometimes indirect or surface transmission method is adopted too. For example, you are having a retaining wall where the backfilling has already been carried out. Now the client is not happy with the with the quality of the concrete in the retaining wall. So obviously we cannot go and dig up the entire backfill. So that time indirect transmission method is adopted too. But it's a very approximate method. You should try to avoid it as much as possible. And sometimes these UPV tests are even used to measure the depth of the crack. And that time you go for an indirect measurement. Again, when you measure the depth of the crack through an ultrasonic pulse velocity test, sometimes it gives an erroneous result. So you need to be very careful. Because sometimes I find that the width of the beam is about some 30 centimeters. Sometimes when you apply the equation, what is given in Bungie or given in your IS code, and sometimes you get a very erroneous result. That you have to be very careful while predicting the crack depth also. So this is something very common knowledge. So if the sound concrete is there, the waves will travel very fast. If there is some reinforcing steel, then it travels much faster. But then we don't do the correction factor for the reinforcing steel because we'll see in the next 2 or 3 slides the method to predict the numbers that have been given to predict the integrity of the concrete is so wide. So the reinforcing steel may have such a great impact. And when you have cracks, naturally the sound waves have to travel through the cracks, so the time taken is more. Narrow crack, sometimes it will be partially reflected. Wide crack definitely will be reflected and you will get unstable readings or no signal will be released. And then voids and micro cracks, sometimes you may get a very low value or sometimes you may get an unstable reading. So general procedure is we have to divide the member into well-defined grid points. There is always a debate on what should be the spacing. 300 mm is what the code has given. But then as a consultant, you can take a call. Because if you put 300 mm for a large structure, then the number of points will increase and the cost of the whole testing goes up. So again, each grid point has to be, the 300 mm or 500 mm or something which you can decide. Consultant can take a call, but they were given a guideline 300 mm is preferable. And each grid point is to be prepared. It has to be smooth. And then we need apply acoustic coupling like a grease or something for between the transmitter and the receiver so that the pulse is properly transmitted. And recording the transit time is done in an instrument. Generally, people use Pandit. And then the velocity is calculated as L/T. That is distance between the two transducers and the time taken. So if the velocity is more, then the quality is more. That is, the time is less, the velocity is higher. So the integrity is much better. Now, the IS code. Recently, IS code has been, past 1 year, has been upgraded. Now, the old 13311 said, any velocity above 4.5 kilometers per second is excellent. Between 3.5 and 4.5, they said it is good, and 3 to 3.5 medium, and below 3 doubtful. And this was very useful to consultants like us because we had a very clear idea that generally when there is velocities are low, which means when the integrity is not that good, the general methodology that is given is grouting with either a low viscous epoxy resin or with a cement. So when the velocities are above 3.5, there is no problem. Then when the velocities are between 3 and 3.5, we found that the grout does not go inside. Generally, the grout does not go inside. And only when the velocities are less than 3 kilometers per second, the grout generally goes in. So it was quite okay. now the recent IS 516 part 5 that has come out with this kind of specification. They say that for any grade of concrete less than M25, any velocity below 3.5 is doubtful, 3.5 to 4.5 is good, above 4.5 is excellent. And for all grades of concrete above M25, it says below 3.75 is doubtful. So this is something which I spoke to my colleague, Dr. Manu Santanam, who's a very eminent concrete technologist, who's also in the Bureau of Indian Standards, present Bureau of Indian Standard. We told them that most of the structures which we are going and investigating are more than 30 years, 40 years, 50 years old. So, the basic idea of this particular table is the code committee, subcommittee felt that the quality of the concrete has to improve because we have gone many notches in the way we do the concreting. So naturally, the service life of the structure has to be good, and then for that, the quality of the concrete has to be good. So they have put some higher threshold numbers of 3.75 and above. Any velocity which is less than 3.75 is doubtful. Now, for consultants like us, we know that any velocity which is less than 3.75 kilometers per second, when it comes in the doubtful category, then as a consultant, we have to give some methodology. Though naturally we are going to say grout, but then no grout will go inside for a velocity which is 3.5 or 3.4, or it doesn't go. So we are worried, and we brought it to the notice of the Bureau of Indian Standard, but then they stuck to their stand that the quality has to improve. But our worry is, what about the structures that have been constructed 50 years back or 40 years back? And when you apply this, then every structure we need to give some kind of a methodology. Anyway, this is something which I don't know, which code has to take a. They have to go a little more into this and then come out with the thing, because I'm very sure any velocity now, as per this code, below 3.75 is doubtful. For example, if the velocity is 3.5, then I'm going to say the quality of the concrete is doubtful. Now the client is going to ask me, sir, you have given me the quality of the concrete is doubtful. Then what is the methodology? Then I'm going to say grout. So now they are going to call for grouting. I'm very sure if the velocity is 3.5, no grout is going to go inside. So I don't know what, so now the past 6 months, we are all struggling how to, circumvent this problem. As a consultant, you have to give grouting because as per the code, it is doubtful you have to give. But practically, we know nothing is going to go inside. So this is something which, we are not able to understand. Now, next is the code test. Why do we test cores? It is basically because of low strength and standard specimens that is in the cubes. And sometimes the designers may like to do a design check, and that time the building may be 40 years old where no drawings will be available. And that time we do the core test to give the designer the FCK value, or sometimes do correlate with other NDT methods. And sometimes there are people who ask for petrographic evaluation and generally estimate the internal condition of the concrete or get information on the carbonation depth, which I'll be covering in the next few slides. And how many cores to be tested? This is again, no code of practice is very clear about it, whether it is an ASTM or ACI or BS standards or Euro standards. Nobody says the quality of the concrete is suspect, so how many cores we need to take. So this, you need to take a call as a consultant. If there is a Q failure, then at least 3 from that particular batch. And if it is meant for in-place strength, as I told you, the designer wants to check a building, a multi-storied building, which is 10 stories, which does not have any, drawing, no GA drawing, no structural drawing, no, FCK value. Then that time we try to take as many cores as possible from each floor. Each floor about 5-6 cores, 2 from the column, 2 from the beam or something, and then try to give the designer some kind of a confidence level for him to, feed it into his StatPro model or any model. So how many cores is a question mark. So I don't think people have to break their, head so much into this. As a consultant, you take a call and take a conservative call. That's all. You can decide on the number of cores. And this is how a core test is done. Most of you would have seen that. So what is the core dimension? Generally, it says minimum diameter 100 mm or 94 mm. But today, the congestion of the reinforcement is so much that we are not able to take a core. Suppose that the core is 100 mm diameter, then the inner diameter is approximately 94 mm. Sometimes the congestion of the reinforcement is so heavy. Most of the time, what we are doing, every year we are taking a few hundred crores, and then generally we are going for a 69 mm diameter core, because cutting of the reinforcement has to be avoided to the extent possible. And generally L/D2 is preferred. Now the new code has given you correction factors for L/D which are not exactly 2. And any L/D equal to less than 1, we should not test the course, because it will not give a proper result. And testing of the course is as per IS 516. L/D should be 2, try to make it as much as possible to 2. And the course with embedded reinforcement should be avoided as much as possible. One is cutting of the course cutting of the reinforcement during a core test. Designers will not be happy about it. Second is core with an embedded reinforcement may give you a very erroneous result. If the bond is not good and all that, then they may not give you a proper result. So as much as possible, try to avoid cutting of the reinforcement from all the perspective, from the designer's perspective, as well as from the core concrete strength perspective. And generally we cut the core. This is a 16 mm diameter core. We cut the cores from the side, bring it to the lab, trim it to the size, and then you can do an UPV also to check whether the integrity of the core is okay. And then we cap it. Actually, sulfur capping, now we are done away with sulfur capping because it is not good for health. And now we are doing it with a high strength, compound. And now cores are tested, and then finally it's done. Then what is the acceptance criteria? Now the IS code says, suppose you are testing 6 cores or whatever number of cores, the average should not be less than 85% of the FCK, not the target strength, FCK. And no individual core shall be less than 75% of the FCK. For example, if you take an M30 grade concrete and you have taken 3 cores or 6 cores, average should be 0.85 times 30, which is approximately, I think, 25.5. And no individual core shall be less than 0.75 into 30, which is 22.5. This is what the IS code says. Suppose it doesn't satisfy M30 grade, then you need to check whether it is satisfying M25 grade and then pass on the information to the designer. So the designer takes a final call. And then from the cylinder to tube, we apply a correction factor of 1.25. So basically, and then for diameter lesser than 100 mm, if the diameter is 75 plus or minus 5 mm, then we apply a correction factor of 1.03. And if the diameter is less than 70 mm, we apply a correction factor of 1.06. So what are the various correction factors? One is for the L/D ratio. Generally try to take an core with an L/D ratio of 2. If it is not possible due to practical scenario, then there is a correction factor that is given. Generally try to take a better 100 mm diameter core, but then due to congestion of the reinforcement, we need to cut the reinforcement. We go for a lesser diameter core. And when we go for a lesser diameter core, apply the correction factor as given in the IS 516 part 4. This is a new one. And then whatever you are getting, multiplied by 1.25 times to get the equivalent cube compressive strength. And then whatever you are getting, take the average and check it with the average strength not being less than 85% of the FCK, and the individual core being not less than 78% of the FCK. So this is how we get the acceptance criteria. And generally, this is a durability test, carbonation test. I think yesterday they would have spoken a lot about durability. The carbon dioxide diffuses into the concrete through the cover concrete and then reacts with the calcium hydroxide and reduces the pH value, depassivating the steel. And then that's carbonation. And one way of doing is getting the pH of the concrete through concrete powder sample. Second is you take a core and then try to spray a phenolphthalein solution. So the whole thing should turn pink. But then there are locations where it will be colorless. So this is a plaster and this is a concrete. So the carbon dioxide has diffused so much into the concrete. Basically, why we do this test is during repair rehabilitation, we always want to chip off the bad concrete. So if the carbonation depth is so much, 25, 30 mm, then we try to chip off that carbonated concrete and then give a fresh concrete. Put a micro concrete or a polymer modified mortar, as the case may be, depending on the thickness. So this is the carbonation test. And then the half cell potential test is it's an ASTM test. Most of you would be aware of it. So we use copper sulfate electrode, and then use a multimeter, and then one is connected to the rod is chipped open and connected here, and and then we have certain R cells potential differences measured, minus more negative than minus 350 millivolts, 90% probability of corrosion. If it is between minus 200 to minus 350, then corrosion activity in the area is uncertain. If it is more positive than minus 200 millivolts, 90% probability that no steel corrosion is happening. For me, this test is again not a very, because most of the structures we go, it's terribly corroded. So there is no point in doing a half cell potential test on the corroded areas, because obviously, it has already got corroded, the concrete has cracked, spoiled, a loss in diameter is there. So generally we use this test because we go to a site, a very huge structure, whether it is a marine structure or a bridge structure. So we are asked to give the rehabilitation methodology as well as a bill of quantity. When you want to calculate the bill of quantity, we need to be very sure with the kind of limited testing we do. So that time we do the half cell potential test on the good location to check whether the visually good locations are in reality really good through the half cell potential test. That's the only case where we want to use this half cell potential test, because any corroded area, there is no point in doing a half cell potential test, because obviously we'll get a value which is more than minus 350, we may get minus 500, minus 600. So generally we use this half cell potential test in a large structure only in the good areas, so that we know that visually good locations are really good from the corrosion potential point of view. So that helps us to decide on the bill of quantity which is required to do the rehabilitation. This is half cell potential test. Then we can do the resistivity test also. We have a resistivity meter also, that also we can do. We don't take it much to the site because you need to properly wet it. Even the half cell potential test, you need to properly wet it. Then the final one is the evaluation of chlorides and pH, because this is a very, very important one, because it is through the chlorides and the pH, the steel rod gets depassivated. So this is kind of a crude test, like, a method of taking a powder sample. What we do is use a drilling machine and drill it from 0 to 20 mm, then 20 to 40 mm, and then try to find the chloride profile. The best way and the limitations are, as far as reinforced concrete is concerned, it is 0.6 kg per meter cube. And for PCC, it is 3 kg per meter cube. But unfortunately, the code is giving 0.4 kg per meter cube for precess concrete. But unfortunately, the IS code says this 0.6 kg per meter cube should be at the time of placing the concrete. They are not telling what should be the threshold numbers after 10 years or 15 years or 20 years, down the line. So this is something which is only for the newly built structure. The chloride should not be greater than 0.6 kg per meter cube. But then most of the sites we go, it is around 1, 2, 3, sometimes even 4 kg per meter cube in marine structures. And the best way to do a powder sample test is, actually my colleague Dr. Manu does it, and I find in European countries like Norway and all, they do this. They take a core, take the core and put it in a lathe, and then use put it in a chuck, and then use a tool, and then cut the powder sample. So that is more precise. Here, when I do with a drilling machine, I cannot do a proper profile, because all of them 0 to 20 or 20 to 30, even though I put a dryer and then try to blow it up, may not give me a perfect thing, but then it gives me some kind of an idea about the chloride content. The best way would be to drill a core and put it in a lathe with a chuck, and then use a tool. So you will precisely find out from 0 to 10 mm what is the chloride content, 10 to 20. So you will know to what depth the chloride has penetrated for suggesting a proper rehabilitation methodology. But then it is very sophisticated, so we go for these kinds of simple methods. And then this is again common sense, like high pH value and low chloride content, not corrosion prone. High pH value but high chloride naturally will corrode because of chloride. Low pH value, it will corrode because of carbon dioxide, and low pH value and high chloride content definitely is corrosion prone. And the last one is the profometer. This is basically profometer or profoscope. This gives you the location of the rebars, and also it measures the diameter of the rebars. But there are a lot of limitations to this. A profometer will not detect a rebar if the cover is more than 70 mm. So that's a limitation. suppose I go and put it in a column. Generally, what happens is while kinking, or from one floor to another floor, maybe if the levels are not okay, then they try to kink the rebar and take it up. So one side there'll be 15 mm cover, the other side there'll be about 80 mm cover. So that time when the cover is 80 mm, this will not detect rebar. So, and then it can predict the diameter of the rebar, but there can be an error of plus or minus 25% in the prediction of the rebar. Hilti also has a much better equipment. This profoscope is about 5 lakhs. That is about, I think, 15 to 20 lakhs. There they say it can be 1 diameter more or 1 diameter less. So prediction of the diameter of the rebar is little dicey. And whenever we do work for some of the IIT professors, particularly for the design check and where the GI drawings are not available, we do the profoscope survey in a number of locations. And then what we do is randomly we chip open after taking the permission from the owner. We chip it open and then cross-verify your profoscope and the thing, because this profoscope may have an error of plus or minus 25%. So you need to be very careful in predicting the diameter. You should not give the designer some wrong numbers. So you can chip open and suppose you are doing, there are 10 stories and you're doing profoscope about 80, 90 locations, you're doing a profoscope. At least in 5-6 locations, you can chip open and then it's worth it to cross-verify the profoscope or the profometer prediction of the diameter with the actual thing that has been given. And then another problem with this profoscope or a profometer is it cannot detect the second layer. It will detect only the first layer. So it will not detect the second layer. So there are a lot of limitations are there. But then this is a tool to start some kind of an idea it gives to start somewhere. So these are the final one is the load test, because everything fails and the IS code says do a load test. You can do ponding, or you can go with a sandbag, or you can go with anything. If you're very sophisticated, then you can go with jacks also. So these are the various things. So I would like to just cap it up. So what are the various methods? One is a non-destructive. What are the various non-destructive? Rebound hammer. Rebound hammer is a good tool, but then it should not be, it's my perspective that it should not be used to predict the compressive strength. And basically it gives the near surface characteristics of the concrete. It gives you the quality of the cover concrete, because it is through the cover concrete your chloride or the carbon dioxide diffuses in. If the quality of the cover concrete is good, then naturally your durability will be good. Ultrasonic pulse velocity test basically used to measure the integrity of the concrete. It tells you whether your concrete has got voids or honeycombs or pores. So if the velocities are less, then we can suggest a low viscous epoxy resin or a cement or polyurea, polyurethane, depending on the scenario of the repair. And now the new code that has come out is little difficult, because any velocity which is less than 3.75 kilometers per second, they say is doubtful. And to us, from practical point of view, because I have a division, I have a sister concern which does a lot of repair, and they're very clear that any velocity which is 3.5 kilometers per second, grout will not go inside. So the code has to take one more call on this. Otherwise, the owner will be spending a huge amount of money. As a consultant, I'll go, the velocity is 3.5. As for the old code, it is good. Now, as for the new code, it is doubtful. So as a consultant, I had to give a methodology. Otherwise, I won't look good. So I give a methodology, and then, the grout will not go inside. Somebody is going to make more money, and the owner is going to pay for it. So that is a ultrasonic pulse velocity test. Why I want you to do it in a 300 mm or 500 mm grid spacing is so that we can map the contour of the locations where the velocities are low and grout only those locations. Otherwise, if the velocity is someplace it will be above 3.5 or 3.75, someplace it will be less than 3. So you start grouting the entire column or the beam, then the grout will not go inside. So the owner will be unnecessarily paying drilling a hole, fixing the nozzle, then grouting. Nothing will go inside. So they will be paying more money. That's why they say whenever there is a doubt in the quality, do it at a closer spacing, so though you know precisely where exactly the locations to be grouted. So that is the ultrasonic pulse velocity. Core drilling is a much better method to measure the in situ strength. Again, there are people opponents of the core test, but to me, core test is a much reasonable test. because sometimes they say the designer, suppose it is a column, the designer will say take the core from the middle of the column where the bending moments are less. And sometimes because of the congestion of the reinforcement, these guys go on vibrating so heavily. Sometimes the aggregate will settle down, and when you take a core from the middle, you may not have a proper distribution of the aggregate. But that's not a a proper reason. The best is, to me, is a core test. And the durability tests are carbonation. So we can spray a phenolphthalein solution and find out the depth of the carbonation. Why we do this is to formulate your repair methodology, how much I need to chip it open. And then we have the half cell potential test. As a consultant, it is my perspective that I won't go and do a half cell potential test in a location where it is already corroded, because I know I'm going to repair that location. Probably I can take one, and the other location, because I had to, I cannot do a very huge testing because it is money. People are not willing to pay that much money for testing. So I have to limit my testing. So that time I do half cell potential test on the good location, the so-called visually good location, to get a feel or to get a confidence that I don't have to touch these locations. If the values are coming good in those locations of the half cell potential test, then chloride pH, it definitely throws more light on the level of the chloride. Again, chloride, it says 0.6 kg per meter cube. At the time of placing the concrete, it does not say what should be the threshold numbers after a few years down the line. So, but then it gives you some idea about the level of the chlorides, and that gives you a better perspective into suggesting a proper rehabilitation methodology. And pH, of course, either it gives you carbonation, either you do it with the phenolphthalein test or do with the powder sample and then do a pH. And then profometer is used to predict the diameter of the rebar or the location of the reinforcement, because when we do a core test, we use a profometer or a profoscope or a reinforcement locator to mark the rebar so that we cut the core without cutting the rebar. For that also we are using a profometer or a profoscope or a rebar locator. So these are the things. So all the tests are good, but then you need to be very careful in interpreting the results and jumping to conclusions with these tests. So it gives you some kind of a feel for you to arrive at a rehabilitation methodology. Suppose you want to go into research and all that, then you have to go a little more into the physics of it and then try to understand a lot of things. There are people who are working a lot on these advanced techniques, but it does not come to the field level so far. A lot of papers are being published, a lot of research is being carried out, but then it does not come to the field level because of the interpretation issues. So this is about the various methods. I think I have another 45 minutes, sir. So now I'll go into the practical investigation situations. So what are the various investigation situations? The stages at which NDT is resorted to. One is during construction, immediately after construction, sometimes after construction, then assessment for repair and rehabilitation, then sometimes for the structural stability and enhancement in the load carrying capacity. I'm having about 5 floors or something. In the 3rd floor, I want to erect a machinery. So whether my structure will have carry the load. So that time also NDT is resorted to. Fire damage, generally fire damaged concrete tends to carbonate. So fire damage is mostly insurance-based investigation. So you have to be very careful. When you do a fire damage investigation, you have to test in the fire damage locations as well as in the non-fire damage locations, because the insurance people will ask you whether this defects were pre-existing. It is like our medical insurance. They were pre-existing or the damage happened only because of the fire. So you have to be very careful when you are doing a fire damage evaluation. You have to do in the fire affected location, not so affected location, and completely unaffected location, so that the insurance guys are very sure about it. And then the post-repair evaluation. So these are the stages at which NDT is resorted to. So I'll go practically at what are the stages. Each stage I will try to define to you. During construction, when NCs are created, NCs are called non-conformities. Maybe the faculty, you may not be very familiar with the way the industry works. Non-conformities are created and Q failures. The problem in the industry is the bills will get passed. Like, if it is a 1 crore bill or 2 crore bill, the bill will get passed only when the cube passes. So when there is a cube failure, then there is a lot of, halla golla happening in the site. And then because the bills will not get passed. So that's the reason why you have to take course. And the contractors are a little hesitant to take course because they know the cubes are being done with so much of care, and they fail and you take a core may fail. Even though there is so much of buffer of 85% of the FCK, still they are not, very comfortable. So they bring a rebound hammer. Rebound hammer, they are very comfortable because rebound hammer predicts the strength on the higher side. So the NC is closed and then the bill gets passed. Sometimes honeycombing or poor quality surface, shutter issues. That time they may do, because there is no point in putting a probe, ultrasonic pulse velocity test on honeycomb naturally will give you bad results. So they may do a repair. And then post-repair, they will ask you to do a UPV. The values come good, which means that the repair that has been carried out is quite effective. So these are the cases during construction. That is when NCs are created, when cube fails, honeycombing, and the consequent repair and post-repair evaluation. These are the stages during construction. For example, there's a chimney, which is under construction in Orissa. And during slip form, they were pulling it and it was dragging the cover concrete, and the contract engineers, without telling the client engineers and the PMCs, they go and plaster it. So when they plaster it, then it goes about 20-25 meters because the chimneys are almost 220 meters, 270 meters tall. Around after 30-40 meters, suddenly the PMC, because it's a very large area, so PMC comes and sees this kind of plastering, stops the work. Then because a chimney making is about 250 odd laborers for a chimney alone. And when they stop the work, because they are worried, because a few chimneys fell down in Korba about 10 years back, then after that people are worried. When there is a poor quality surface, then they stop the work and they want a consultant to come in. That takes about 15-20 days. And, the laborers get stuck and then a lot of money is wasted. And if the consultant is a straightforward consultant, he will take a core and then close the issue. Then because doing a UPV test on this kind of a bad surface, obviously you know that you're not going to get proper UPV values. The best way would be to take a core and tell the client and the PMC, your problem is there only in this thing. I'll show you. This is another chimney, which again has a poor surface. So cutting a core in a chimney is always a headache because you need to have some julas and then go on top and then cut the chimney. So then you take a core and tell the client, sir, your problem is there only in the, the cover concrete location. So you can go out with the rehabilitation methodology and move on. And your core of the, shell is fine. So this is how we need to approach the problem. You can do UPV and make more money, but then the UPV, obviously with this kind of concrete, you will get unstable reading. So you have to be a little more, very ethical in your approach to it, because making money is one thing, being ethical is another one. So in this kind of situation, just take a core and then tell the client and then close the issue so that, things move faster. And immediately after construction. This is very rarely used immediately after construction because nobody wants to check the quality of the concrete immediately after construction because everything is settled with the cube results. Now, this is to settle future disputes between civil and other disciplines of engineering, as in the case of the power plant structures, TG columns and TG decks. Now this has become a tender specification. For example, this is a TG deck, which may have 14 columns or 7 columns, and then a TG deck. And this may be a 600 megawatt. 1 megawatt is 5 crores, 600 megawatt is 3,000 crores. And the owner, when he puts 3,000 crores and then puts a TG on top of that, after some time, suppose it, it trips, then the civil engineers construct and then move on. Then it is taken over by the electrical engineers and mechanical engineers. And there will be very few civil engineers to do maintenance. So the mechanical or the electrical engineers invariably find fault with the civil engineer because you have made this column and deck slab, TG deck so bad that, my machine is tripping. And one day trip is 5 crores loss for me. And on the financial side and on the societal side, the 100 villages may not get power. So, so to settle this dispute, BHEL in the 90s, they said, once a TG column is made and the TG deck is made, then a UPV test will be conducted. And if the UPV test is fine, then the TG will be erected, and any issue later on due to any vibration or any tripping, the onus of responsibility will fall on the mechanical engineer. Because there could be a misalignment of the machines, and a mechanical engineer will not like to take up that responsibility. So simply passing the buck to the civil engineer when the columns will be good. So once you do a TG deck and a TG column, ultrasonic pulse velocity, and establish that the quality of the concrete is perfect, then the future problems, will be the onus of responsibility will go to the mechanical engineer. This issue was taking place a lot in the 90s, and that has been now settled once and for all. Now, any TG deck, because these are all quite expensive, like 3,000 crores or 4,000 crores of money is being dumped in a 600 megawatt power plant, and they don't want to take any risk. So UPV is done in 300 mm grid spacing or 500 mm grid spacing in the TG columns and also in the TG decks. So once it's cleared, and then I have done about 70 or 80 TGs in my 35 years experience, except this TG which is in again in Orissa. All the TGs I never had problems. This is a TG deck. Poor concrete, maybe design miss issue, then shutter issue, a lot of issues, and they created this kind of a TG deck. The owner was completely upset because this is a vibrating structure, it's not a static structure. If it is a vibrating structure, then it may trip anytime if your quality is bad. So there's a lot of tension. This kind of TG deck they produced. So immediately after construction is to settle the future disputes. Mostly this NDT is done for the third one, assessment for repair and rehabilitation, including accidents and failures. So this is to assess the condition of the concrete from the durability issues, such as suitable repair and rehabilitation method. Most of the NDT what we are doing today is generally for repair and rehabilitation, because people don't want to spend a lot of money, because each rehabilitation is costing you 30 lakhs, 40 lakhs, or sometimes few crores. So they don't want to take a call like that. And the designers also, they don't want to take a call on a structure which is already 40 years old. So they want to do some minimal testing to assess the condition of the concrete before any repair and rehabilitation is taken up. And this is also in case of accidents, poor maintenance, fire, so many things. For example, this is a corrosion affected chemical factory. I'm just telling you the conditions. This may be an institutional building or a factory building, or it could be a hydel power station which has not been functioning since construction. Again, NDT is utilized. Or it could be a bridge where you find, the entire, girder, complete spalling of concrete and, corrosion and exposure of reinforcement has happened. And there's an NHA bridge. Or it could be a bridge where a few spans have fallen down due to certain accident. And that time, the people have to understand the remaining condition of the remaining two spans. These are all pre-stressed bridges. So that time NDT is resorted to. And then doing an NDT in a structure like this is so difficult because, scaffolding becomes an issue. So, you need to fabricate a movable scaffolding thing which moves along with the span, and, and then marine structures. This is a barge which has gone and hit a mooring dolphin and knocked off a, pile. So owner will be worried, like, one pile has gone. What about my condition of the remaining piles and my deck, the mooring dolphin, whether it's okay. That time NDT is resorted to. Or again, this is another jetty in Visakhapatnam where this pile has been knocked off by a barge again. One pile is just knocked off. So that time NDT is resorted to. Or it could be a dock jetty which was constructed 40 years back. So much of corrosion. This is in West Bengal. And, this is another approach trestle in Tamil Nadu, where a lot of corrosion is there. And again, this is an oil jetty in, again, Tamil Nadu. You can see the corrosion here, a lot of corrosion. I'll just put it as a case study. And what is happening is, in the earlier days, people are resorting to shotcreting without any shear connector. So within about 5-10 years, whatever repair they had carried out is coming off. So again, more money spending. So again, that time NDT is resorted to, because they want to get the bill of quantity, and when they want to get the bill of quantity and the methodology, they want to be very sure about the condition of the concrete. And again, this is another jetty head where you find that they have put some weld mesh and shotcreted. The shotcrete has come off after 5 years. So again, this is another coal jetty again in Tamil Nadu, and you can see the kind of corrosion happening. And this is another jetty head again. Or this could be a naval jetty at Vizag, where again a lot of corrosion, and because these are all marine structures, corrosion is inevitable, happens. And if the corrosion is detected at a much earlier stage, then the repair cost will come down, but it doesn't happen. It happens only when it goes very bad. People start, worrying and then bringing in consultants. And then the fourth thing where entity is resorted to is structural stability or enhancement of the load carrying capacity. Old RC structures with no record of GA drawing, grade of concrete, reinforcement details. You go to many structures, 10-story, 12-story, there is no GA drawing, no reinforcement detailing, no foundation detail, no grade of concrete. That time we basically do the NDT to give an input to the designer on the above aspects. So we do a profoscope and then give them an approximate idea about the reinforcement detailing, take the core, give the grade of concrete. And from the durability point of view, we do the UPV test or the powder samples to give a confidence to the designer, so you can go ahead with your modeling. And again, microzonation. For example, I'm coming from Chennai. Chennai was in zone 2. Now it has become zone 3. It's fine. But what about public buildings? Because 13920 zone classification, detailings, they're so different. So some owners are getting, they're little getting worried due to microzonation, whether my building will be okay. Particularly, you look at government buildings, hospitals, these are very important because this is a thing which drives the whole, government. So those buildings, whether they are okay. So that time NDT is resorted to because they don't have any drawings, no GA drawing, no grade of concrete, no foundation detail. For example, I'll give you one case study where this is a building in Chennai where the family got into trouble and then the trust took over, and the judge who took it over, who became the chairman of the trust, he wanted to get the stability certificate before moving on. So to get the stability certificate, I approached IIT and then we were helping IIT in this work. No drawing, nothing. So we had to do a rebound hammer from the durability point of view, UPV from the durability point of view, core for giving the input to the designer for the FCK value, profoscope survey, again, to give the designer the reinforcement detailing. And not alone, we stopped with the profoscope survey because it was 10-story building, and we shipped it open at more than a dozen locations to cross-verify whether my profoscope readings were okay with the actual thing. Otherwise, the corrections had to be carried out. And second layer of reinforcement, whether it was there or not, we can't do with a profoscope survey. And then we took a JCB, dug the foundation, and then found out what kind of a foundation that has been given so that the professor can feed it into his model. So this is another, case where, your entity is resorted to. So it is during construction, then during construction, maybe for NCs and other issues, quality issues, then immediately after construction, which doesn't happen in our country except in the case of the TG decks and TG column, because even with a 1,000 crore project, once a project is done, nobody goes for a quality thing because they say that things have been put into place, QAQC, things, records are there, so they don't want to go for this. And the third case is for the repair rehabilitation, corrosion. People don't want to spend too much of money for testing. At the same time, they do want to spend that little amount of money because they are spending a huge money on the repair and rehabilitation. So that is one. Third and fourth is for the stability certificates. They are going for NDT because no GA drawings are available. And that time the designer requires all these data. So that time, he goes for these kinds of tests. So these are the situations where NDT is resorted to. So as a consultant, doing how many number of testing, how many courses I need to take, how many UPVs I need to do, it depends on the individual consultant's prerogative or his confidence level. Because today, when you are to test more, people are objecting because it is costing money. So they don't want. I mean, I'm giving you from my as a consultant perspective. People will say, why with such? How did you do with such a limited number of testing? How did you manage to give a rehabilitation methodology for 2 crores or something? It's very difficult to defend. So that's why we try to do not too much. At the same time, you can't do too little. So you have to strike a mid path. What is that mid path? Is something very difficult to predict. So another, sir, what time I need to stop, sir? Sir, Professor Ishwar Reddy, what time I need to stop, sir?
Yes, sir. You can
Sir,
take another 15 minutes, sir.
Okay. So 20 minutes, sir. I have 4 case studies. I'll have
No issue, no issue, sir. Go ahead, sir.
I'll stop with that. 7:50. Okay. This is the first case study which I want to project. So I mixed it up in such a way that you get a feel that you get a feel how these tests can be used, because ultimately as a consultant you have to solve the problem of the client, because the client puts so much of faith in you. He calls you as a consultant, and then you have to solve his problem. Whatever case studies I'm going to present, it may look very easy because I'm going to do it in 4 minutes, 5 minutes. But as a consultant, every side I walk into, I'm a little scared, to be very honest with you, whether I'll be able to solve this problem, whatever problem. Here was a case, it's a hydropower project. This I did when I was in SCRC. This is a power station which was about 40 kilometers from Srinagar, and it had 3 units of 30 megawatt. 30 megawatt is nothing today in India. Even the rest of the country, because we have so much of coal, we are making 600 megawatt. So 1 second, I'll just take a. We are making so much of a thing, but in Kashmir, they are completely dependent on the hydropower plants. And they made 3 units, and the work started somewhere in 83. And then it was completed in 1998, because that time there were a lot of issues, insurgency and all were happening. But then after they started, and then only 1 unit was functioning. Few units were not functioning till 2004. But further, 30 megawatt is something big. Here for us, 30 megawatt is nothing. So 2 units were not functioning, and then they brought in a lot of consultants, and they were not able to solve the issue. And then finally they came to SCRC. And then when we did the initial inspection, I went from the entity point of view, from the concrete point of view. Then fortunately for me, I took a vibration expert, because these are all hydropower stations, are all vibrating structures. So by doing a simple UPV rebound hammer and all these durability tests, you are not going to find out why the equipment is tripping. So we took a vibration person. Ultimately, it so happened that without the vibration studies, we could not have solved this problem. So they did they usually put the pickup and then run the equipment at various RPM, 300, 500, because it runs at I think 3000 RPM or something. I'm not very sure. So they run it at various RPM and start measuring the vibration levels. And then they put it in the various columns, because you go to a TG, you go to a idle power station, it has many levels, many columns, many slabs, many beams. As a consultant, it is a nightmare for you to understand why the hell is tripping, why the machine is tripping. So we need to narrow it down. So you can't go and test each and every column or a beam or every element in that particular power. It is very huge. So these vibration studies people, they started putting the what is it called? They started putting the pickups and then running the equipment at various RPMs, and then trying to get whether the threshold numbers are going up from the vibration point of view. And simultaneously, we are doing UPV in the various columns, and then doing the durability was not an issue, but still as a consultant, you have to do all those things. And finally, the vibration team said, the small 1 meter by 1 meter pedestal, they're getting, it's called upper bracket or something. They were getting a lot of vibrations. They told us to focus more on these brackets. There are about 8 or 12 brackets, small, pedestals like this. And when we did the UPV, the values are coming very bad. Like, we are not getting any reading. And whereas in the case of the other columns, your velocities were so high, there was no issue. So we felt that the problem could be only in that small, the pedestal. It's called the stator support pads with the LGB floor. They must have undergone a lot of damage, and then we decided that we had to do the repair. But only right decision we took was 2 units were not functioning right from the inception. So these are all small 1 meter by 1 meter blocks. Generally, when you get a higher vibration and lower UP values, the general tendency is to go and grout it. Here we took a call. It's such a small thing. We can remove the equipment and then break the pedestal and then make it into a newer one. Put a fresh pedestal. And ultimately, that that decision worked out properly, because when they broke it open, they found that the tie rods of the equipment were not properly welded to the pedestal. That was the reason why it was creating. Looks very simple, But then, it was by sheer chance that we told them to break it open. General tendency for any consultant when he doesn't get a proper UPV value is to go and grout it. But looking at the long-term issue of this particular plant, and since a lot of consultants have come and gone, people are not able to, think did not want to take a chance. We said break it open because it's not going to cost you any money. When they broke it open, they found that the welding was not okay. So they broke it open and then repaired it, and then post-repair investigation was completed in 2006. Until I heard about 4-5 years back, all the 3 units were running successfully. And this is a repaired pedestal. We took the readings were coming good. So they are coming very high. So this is one case study. This case study, I put it basically because a lot of people think that working in a team is always good. For example, if I had done so much of NDT, I know everything, and then I go with that thing, I would not have solved this problem. Unless, because it's vibrating structure, get a vibration guy. It's better. You will be able to solve the problem. Otherwise, you will be going round and round. You won't be able to solve the problem. So it is not very specific. What I'm trying to tell the faculty is, it is not very. There is no, bracket kind of a thing, black and white thing. You'll do this to solve the problem. So you need to think, and then you go along with the flow, and then see if you're not having core competency in that area. Bring in people, work as a team, and then try to solve the problem. So this worked successfully for us as far as this particular thing is concerned. Because without vibration studies, my UPV would have told everywhere it is good. I would not even have gone near that pedestal. Because it's a small one, I wouldn't have bothered, because the time is limited. Costing again makes a huge impact on the testing. Even though I should not be telling it to the academic people, costing makes a lot of impact in the testing. Okay, because you cannot be going on endlessly testing because it is money. The money people are not willing to give more money because they are having their own constraints. So with that limited thing, we need to arrive at something that has to be very sensible. This is one case of a idle power plant where issue was solved with vibration studies. And second is I have taken up a bridge. This again happened in somewhere around 2005, 2006, I'm not very sure. This is in a place called Daman. Daman is very close to Vapi in Gujarat. It's about 2 hours drive from Mumbai. And this is a bridge. This is a union territory. If you look at this bridge, one side is a residence. The other side are the government buildings and the schools. So this bridge may be not more than 500 meters. This is a very, very important link to connect the people to the schools and the thing. And if the bridge is, what happened was this bridge was constructed in 1967. I'm just making it as a story so that you're connected to it. 1967 or 68, the bridge was constructed. 500 meters away is the sea. So a lot of corrosion, a lot of chlorides. And that time, during the construction, I heard that the well foundation sunk. Because the well foundation sunk, the PWD had made a steel truss to support the deck slab. But unfortunately, that steel truss was not painted, it seems. That's what the engineers they told. And since steel trusses were not painted regularly, they corroded. And, and people were complaining there was a lot of vibration and then a lot of noises, and then people never bothered. And I mean, the authority never bothered. So one fine afternoon, when the schools were closing, 3 or 4 spans came down, killing about 30 people, school children, mostly a lot of children were saved. But then that is one side, people losing their lives. Second thing is social. People have to go to colleges, schools, people have to go to offices. Then how do they go? So they had to use these boats. So it was very difficult. People are suffering because if they had to go to the other side, then they had to travel 7 kilometers through a causeway. And people coming from Bombay, that June month, there is a huge, flooding. All the causeways will be flooded, and then they simply cannot go anywhere. So the PWD came to SARC that time, and then they said, why don't you rehabilitate these 3 spans, and then we start constructing from the other side. Again, I'll tell you a consultant's mindset. Already well foundation has sunk, and already, they have done some rehabilitation. Fine. 3 spans or 4 spans have come down. Now they are putting a huge responsibility on me and all priestess girders to give a certificate to the remaining 3 spans. See, the consultant's mind, and that to a common consultant, people are worried, but they will take up the challenges. But then it is dicey, like, you want to give a certificate or something. So in this case, this designer, who also happened to be my director, he said, I want more testing, because when I'm going to certify it, I want to be 100% sure that, so you do as much testing as possible. So in fact, we went through each and every span, and a lot of tests were done, even in the well foundation, everywhere. And so what are the structures that were investigated? Again, this was basically done to give a input to the designer, because the designer had to ultimately come with the load carrying capacity, and there is a lacuna in the load carrying capacity. He has to come with the rehabilitation methodology. So there were precast concrete girders, deck slab, reinforced concrete piers, abutments, well foundation. These were the structures investigated. We did all the visual inspection, including the bridge bearings. UPV test was done on the girders, and then the rebound hammer test on the girders, core drilling on the girders, piers, abutments, well foundations. Then, there's durability tests like chloride, pH, all those things were done. And then again, because C was there, then they had to fabricate a suspended, platform, and with a roller, so it moves and then dismantled, taken to the next span. And the girders, diaphragm walls, deck slab, all that were investigated. Cores were drilled from the foundation. And then because it was a pre-stress girder, I'm not an expert on core trepanning, but I can give you a fair idea. We paste a strain gauge on the girder and then take a core drilling machine and drill about 2 to 3 millimeters. When you drill it, the strain is released, and that is measured through the strain gauge in an equipment. And so the strain. And E value, you can find out it is nothing but 5,000 root FCK, because we are taking so many cores. So FCK value is known, 5,000 root FCK we can find, E value is known. So E value is known, strain is measured through this core trepanning method, so you get the stress. It may not be a proper available pre-stress, but it may be around 80-85%, because SCRC has got a lot of correction factors through experience gained in so many years. So they can get an approximate level of the pre-stress, because the designer has to know the level of the pre-stress for him to come to any conclusion on the load carrying capacity as well as the rehabilitation. So core trepanning method was used to get the loss and pre-stress, and then all the values were tabulated, given to law, and we did a number of testing, because the designer was, he didn't want to, he said, test, don't bother, test it, test as much as possible. And then a lot of chemical analysis, because it was very close to the sea, and we found a lot of corrosion also. Ultimately, the designer came out with the external pre-stressing as a rehabilitation methodology. I think Fresnay did the work, I think. They put the cables, did the external pre-stressing, and then rehabilitated it. And then we did a load test using sandbags, and the toll station was used to measure the deflection. And then the bridge was cleared. And then from the durability point of view, we had given some grouting wherever there was some issue, and then a silane siloxane coating, because we didn't again want to take a chance with this bridge. So silane siloxane coating was given so that it does not allow the chloride to diffuse into the concrete. And then the bridge was rehabilitation was completed, and from the other side they did the new construction, and then it was thrown open. So here is a case where NDT was carried out to give more of an input to the designer, so that he arrives at the load carrying capacity or the stability or whatever you call it, and then based on that, any lacuna, the rehabilitation methodology. So this is another case where NDT can be positively used. And this is all, and the third case study which I'll be projecting is more on the durability point of view. This is a LPG berth in a port in Tamil Nadu. We do a lot of marine structures for IIT Madras Ocean Engineering Center. We do a lot of non-destructive testing, and then give the rehabilitation methodology along with the bill of quantity. And Ocean Engineering Center being very strong in the design and other things, they use this data, and then their scope will be much more, and our scope is very limited towards the condition assessment. So what we, in a marine structure, you may have a mooring dolphin. Mooring dolphin is a place where you tie the ship. Like the ship is, comes into the breasting dolphin, and it is, in a fender, it stays there, and then with the rope, it is tied into the mooring dolphin, and all those structures are made out of reinforced concrete. So the scope and objective of the work is done. Mooring dolphins, there were 6 numbers, so 75 points in each mooring dolphin. Don't ask me how you got 75 points. it is all worked out based on so many things, costing and other things. At the same time, being an IIT project, then we need to be careful, because when it goes for a third-party vetting, we should not be pulled up, because with such limited tests, how did you arrive at the methodology? Because so breasting dolphin 4 numbers, so we had fixed some numbers, and FCK code test, even though it's a durability issue, code test we have to do, because the designer has to be very confident about the FCK values. So we did core, carbonation, half cell, powder samples, everything. And visual observation we found in the mooring dolphin, I'll not go through because lack of time. We found in the mooring dolphin RC piles, steel liners were damaged, spalling of concrete, exposure of the rebars, for example, exposure of rebars, and all the steel liners of the piles of the mooring. This is a mooring dolphin. They're damaged. And if you look into the breasting dolphin, again, steel liners were damaged in the RC piles, cracking, spalling of concrete, and then cracking was noticed in the top floor of the slab. See here, you see all the steel liners were damaged. Here, a lot of cracks in the deck slab. And then central unloading platform, so much of distress was there. I'll not go too deep. I'll show you the form of photographs. The pile that is showing cracking and girders, spalling. The flange portion has issues, corrosion. And here you can see in the walkway, a lot of things have fallen. And then, I mean, hardly you see the rebar completely corroded. And this is a firefighting structure. Again, you see that, a lot of spalling, corrosion. So we did NDT testing, rebound hammer, then UPV, and then the core testing, and then half cell potential testing, powder samples, and summary is that UPV tests showed good results, because UPV tests were generally conducted in the good location. Again, as in the case of a half cell potential test, you can't go and do a UPV test on a bad location, you'll get definitely bad results. So when you're giving a bill of quantity, you have to be very sure. I cannot give a bill of quantity only for the bad location. I need to check the good locations also, because these are all very old structures, and in a marine environment where there's a lot of chloride. And the core tests were good, 31 to 14.7. So the designer gets a confidence. And half cell potential naturally will be more than minus 350 millivolt, even in good location, because it's a chloride infested. And abnormally high chloride numbers, and pH of the samples were quite okay. So the corrosion of the rebars is mainly due to chlorides. And the rehabilitation methodology we gave was distress RC piles in the splash zone, underwater microconcrete jacketing, and in the above the water level microconcrete jacketing, minor distress with polymer modified mortar, top floor to be removed and then redone with a floor hardener. And then we gave a Degard, silane siloxane. Degard is a commercial name for phosrock. So they can use anything, silane siloxane coating, acrylic aliphatic type. And then methodology is basically remove the damaged concrete portion. For that, the chloride levels and the chloride thing to whatever level, chip open the unsound concrete, and then provide shear connectors, because the old concrete has to bond with the new concrete. You have to provide shear connectors. In some of the ports where they did this shotcreting, we found that the shotcrete was coming out because there was no shear connector, bonding the old concrete with the new concrete. So shear connectors have to be given. Then if the rod has undergone more than 30% loss in diameter, you have to put additional reinforcement, connect it to the shear connector, then give the form work. And sometimes, we give self-regulating anodes, because it delays the onset of corrosion. That's a different topic by itself, so we'll not go into it. And then we put microconcrete. Why the cost is going up is microconcrete, because the normal concrete itself, if it is about 40 mm, 50 mm, it's very difficult to place a normal concrete. So we go for microconcrete. 1 cubic meter of regular concrete is 4,500. 1 cubic meter of microconcrete, 50% chips is approximately 50,000. So that's why all these repair values go up like anything. So then we need to give a curing compound, because these are all marine structures. Curing may be difficult. Then we give a protective coating. Because we are giving a self-regulating anode, you can provide a monitoring box, so they can take every year half cell potential, understand whether any onset of corrosion is there. If there is any onset of corrosion, they can go there, remove that self-regulating anode, and put a new anode. So each anode costs 1,000 rupees. So it increases the cost, but then it is good for marine structures. So we prepare the abstract. what is the quantity, what is the rate, and then surface preparation, anchoring the main reinforcement into the pile, into the deck slab, additional reinforcement, shear connector, sacrificial anode, anti-corrosive coating, epoxy jointing compound, formwork, microconcrete jacketing, underwater microconcrete jacketing, polymer modified mortar, then curing compound. Here, because the decks top of the slab had issues, demolishing, then concreting, floor hardener, then protective coating with the silane siloxane, debris removal. So the whole thing comes 4 crores. That's a huge money. That's a lot of money. Things could have been better if people had moved in much earlier and then stopped the corrosion. But then they allow it to spiral out of proportion and then do this. But then that's how things happen. And this is another bridge, NHA bridge. Sir, I'll close it, sir. NHA bridge. Here, we had a lot of difficulty with in finalizing the scope because they were not willing to pay that money. I don't want to go into the background. So they didn't want to pay the money. So we were worried. Like ultimately, any NHA bridge, you do a NDT test and give a methodology or a bill of quantity, will be definitely vetted by a third-party professor or third-party consultant. So he'll say, how you will with such a bridge, only 200 points you're done, and then come out with a rehabilitation methodology which is costing me 50 lakhs, 60 lakhs. So we had difficulty in trying to convince a client. Ultimately, we need to go through because it is business. So we need to go with the project, and then we have to be careful. So this is the scope of work, and then this is a bridge in the Chennai-Bangalore highway. Piers, we didn't have any issue. We did all those tests, whatever. I don't want to repeat it. We did not recommend any rehabilitation. The piers were perfectly all right. The pier cap, there was some issue. So we had gone for a dry spray mortar because this bridge is still in operation. Large containers move on the top of the bridge, and we cannot stop the traffic. So if you have to give some microconcrete jacketing and all that, then you have to put a core through the deck slab. Suppose your beam has to be rehabilitated or your slab has to be rehabilitated with microconcrete jacketing, then you need to put a core, make a space for you to pour the concrete. So that's not possible. So everywhere we went with the dry spray mortar, M40 grade concrete. So we went with the dry spray mortar, and here you can see the girder. Huge containers are moving on these bridges. And the factor of safety is so high. So despite so much of spalling and exposure of reinforcement, the bridge, there is no problem to the bridge. Okay, so here what we did was we did all the testing, and what we did, the girders were not that good. So the girders were grouted with low epoxy resin, and all the girders we had given with the repair with the dry spray mortar. And most of the bridges, you will find that the rainwater sprouts are invariably clogged or they are bad. So the cantilever portion always gives a problem. So here also we had a lot of problem with the cantilever portion of the deck slab, where it is overhanging, where they put the rainwater sprout. Rainwater sprout is invariably clogged. Very simple thing. The maintenance is a problem. Simple things lead to issues over a period of time. It keeps accumulating. You will see so much of corrosion. Rebar corrosion, everything. See, you have to pay unnecessary money. Instead, if they had done the rainwater sprout properly, gone there every 3 months, 4 months, and then rectified it, all these problems will not come. And cantilever deck slab, we recommended using again a dry spray mortar because microconcrete jacketing was just not on, because we had to cut a core through the deck slab where the traffic was moving. So abutment was perfectly all right. So no rehabilitation methodology was given. So final rehabilitation methodology was grouting all the RC girders, deck slab using a low viscous epoxy resin because they were in bad shape. And extensively, there was only one girder which was extensively distressed that we recommended dry spray mortar. General methodology, that removal of the damaged concrete, grout, then anti-corrosive coating, and then apply the dry spray mortar or the polymer modified mortar in some of the cases, or microconcrete jacketing in some of the cases, curing. I'll just stop with that. It's repeating. So prepare the bill of quantity. Here you have to be very careful because it goes to NHA government body. So you have to be very careful what you have to properly, when you are estimating the quantity, it should be length, breadth, everything should be there. Then you give a detailed specification, and then the bill of quantity. Here I think it is 51 lakhs is the cost for the rehabilitation. Then each number has to be properly justified with this kind of a thing. So this is how it is done. In the summary, in most sites, only routine investigations are done. It's because of a combination of several factors. Limitation of the test and the equipment are not well understood. Just because I'm having some equipment, I think I'm great, and I need to use it, and I need to testify it. It is not required for any consultant, because basically your client is approaching you to solve the problem. How you are solving the problem with the limited with the equipment and the limited limitation of the equipment, you should be very, very frank. Then it solves a lot of problem. And the focus is more on closure of NCs and finding immediate solutions to durability related issues. And this does not often address the real cost as well as the service life of the structure. And experience has shown that it is imperative to use some advanced techniques to fully understand the cause of distress. There is a clear need to adopt more reliable investigation methods that interface with other disciplines of engineering and physics. This is very important, but may take a little longer time. A lot of people are working, but the confidence level has to be built up so that these things can be taken to the site. As of now, we are doing rebound armor, UPV, core, half cell, resistivity, powder sample. That's it. Then because we need to solve the problem of the client. See, bottom line is you try to solve the problem of your client and try to do it as much ethically as possible. That's all. That's the bottom line. You may have a lot of theoretical questions on this. It is very difficult to answer many questions because how do you fix the numbers? How do you fix the number of cores? Nothing is there. It is, your experience, and, it takes a little longer time. But, with experience, you can do it. It's not a problem. So this is what I just wanted to share with you. I'm sorry, I've taken overshot by 5 to 10 minutes.
No issues. No issues.
So this is what I wanted to share with you. The methods, what are the various methods, the limitation of the equipment, and where exactly today in the construction industry, NDT is being resorted to during construction, immediately after construction, but mostly it is repair and rehabilitation. And fire damage, where insurance becomes an issue because they are claiming so much of damage. Then that time NDT, and that time you have to be very careful. Once I got caught with an insurance guy because that was my first job, I went and took it only in the fire affected location. That fellow took me to pieces. He said, "Boss, how did you know that these locations did not have the defect earlier? So you have to do it in other unaffected locations also." So, you learn, every site you go, it's a learning experience. And then fixing the numbers, it's very difficult, sir. It is because money plays a huge part. Even though the owner is going to spend 50 lakhs or 60 lakhs or 1 crore for a rehabilitation, when it comes to testing, he has a constrained budget. So then at the same time, as a consultant or as business, I'll be very open. As a business, you need the job, but at the same time, you have to be very sure about your name. Like it goes to a third party and then vetting, and then he said, with limited testing, how did you get this 1 crore or 50 lakhs? So it's kind of dicey. So you need to take it along, as you go along. So this is what I just wanted to share with you. And thank you very much. I thank again Professor Ishwar Reddy and Yuvraj for giving me an opportunity to speak to all of you. Thank you so much. And any questions are there, I will take it. If I know, I'll give the answer. Because for me, every day is a learning process. And sometimes I'm also forced to do NDT on in elements and structures where it is absolutely not required. For example, a plastic shrinkage crack. I'll tell them, "Sir, plastic shrinkage crack, why do you want to do NDT? Sir, they have put an NC. Do come and do it. You want to close it." So I go and hit a rebound hammer and I don't give the strength at least. I tell them clearly, "No, I will not give the strength. I simply say the number and the surface is good or bad. Sir, that is enough, sir. We'll close the NC." This is crazy. I don't know why such things are happening in the industry, and wrong tests are being done for wrong issues. See, these things happen, and then please understand the limitations, particularly faculty when you are teaching or when you are when you are doing any work. See, understand the limitation and be careful about the limitations. Because the easier thing is rebound hammer is 80,000 rupees. Take it, hammer it, give the strength. You be very careful, sir, on this. So any questions are there, I'll take it, sir.
Yeah, thank you, sir.
Sure.
You can stop sharing, sir.
Yeah, okay. Sorry, sir. Yes, sir.
Yeah. So to summarize,
Yes, sir.
So Dr. Balasubramanian has enlightened us on NDT testing methods, so which are used for retrofitting and rehabilitation. So he focused on the fundamental limitations of rebound hammer, and then he focused on UPV test methodologies, and then codal provisions that are available and their limitations. Then he elaborated on core testing. So how core testing has to be done, what are the specifications, how we need to be very careful when a core is taken and tested. Then he has discussed elaborately on rebar location, how rebar has to be located. Then the load tests that are to be done after the rehabilitation work is completed. Then different investigation situations that are to be understood. Then what are the stages of construction, so where NDT is to be resorted to. So then he explained about NDT for different structures. So then he elaborated NDT for performance enhancement of structures with respect to stability and load carrying capacity. Then ultimately, so the case studies. So fabulous case studies have been presented. So one is on Hydel power plant, then another one is the river bridge. So then a third one is marine structures, this is the components of the marine structures. So it's a very different experience with regard to case study is concerned. So different environments like an NHA bridge, he has chosen 4 different case studies to give glimpse of how rehabilitation and retrofitting has to be understood and implemented. So with due care. So then the last one is nothing but, so ultimate thing is nothing but, so the limitation of the understanding of the rehabilitation testing and implementation. So the capacity building that is required, and awareness among the structural engineers and civil engineering fraternity with regard to the rehabilitation and retrofitting. So with this, I thank Dr. Balasubramanian for his valuable lecture. So now I request him to take some questions, so which are posed by the participants. Shall I go ahead, sir?
Sure, sir. Sure, sir.
Can we evaluate other properties like porosity quantitatively from UPV or some acoustic type property?
Sir, if you want porosity and all, you can always drill a core, and you can do that absorption test. You take a core and then coat it on the all round, and then put it in water, submerge it in water, take weight. It is limitless, endless. You can do anything, but you have to take a core, take an 100 mm core or something. Then there are some DIN standard or IS standards for porosity and all that. You can do it. But the problem, sir, again, I'm only telling from the consultant perspective, from the client thing. These are all nice things for research, for faculty to develop. But the client doesn't want it. He says, sir, my structure is bad. I want a rehabilitation methodology. That's it. But your point is technically, yes, it is possible. Acoustic emission and all, I don't know, sir. The interpretation becomes, are they taking it to the field? I'm not very sure. Even the impact echo, what SCRC has, they don't take it much to the field. They are taking, I'm not telling they're not taking, but they're taking, but not much. That's my feeling. And porosity and all, yes, after all, it is what, sir? You take a core and then trim it, and then do like how you do for a regular disc shaped specimens, you can do the porosity, like coating on the, so that there is a unidirectional flow. You coat it on the other side and then take weights, and there are equations we can measure porosity. That's not a problem. But
so out of core test and rebound, out of core test or rebound hammer test, which gives more reliable FCK values?
Only core, sir. Only core. Rebound hammer will always predict a 1.5 times more or 2 times more. And that's why it is very contractor friendly. And that's one of the reasons most of the contractors prefer to do a rebound hammer test.
Yeah, we are building structure with a river sand and quarry sand or manufactured sand. Okay. In your finding or opinion, which structure is more durable? What are the precautions to be taken for a durable structure?
Both the sands are fine. There is absolutely nothing wrong with both the sands. Only issue with an M sand is in 150 micron, it's more fine. Like, because it is more fine, it tends to absorb more water. So the workability may get affected. So all the admixtures that are being formulated today by various companies can take care of this sudden, loss in workability of the M sand. And generally in RMC, when you use an M sand, the only issue could be this. Well, but for plastering, because this is M sand particles may not be spherical like river sand; they may be cubical kind of a thing. So the mason finds it difficult to plaster. He has to put some more effort. That is the only thing with the M sand. As far as concrete is concerned, there is absolutely nothing wrong with an M sand or a river sand. Both are the same. Only thing is you be very, because we don't get M sand from a quarry which has a VSI. VSI is called vertical shaft impacted technology. Any sand, any crushed stone dust or whatever you call it, you put a VSI technology, you get a sand which is perfectly fitting into zone 2. Unfortunately, the river sand, the M sand, what we are getting, they are very fine. That 150 micron, that passing may be more. So they are fine. They absorb more water. The workability will get affected.
Yes, sir.
How to retention of the workability. So they are formulating the admixtures in such a way that it is taken.
Yes. How to test the concrete elements by holographic method?
I don't know. I honestly don't know. What is it, holographic and all? I just that's what I told you. Most of the advanced methods, I just don't know. Yeah. There are so many things that are flying around, but really are they being done? I don't know. Maybe they get some research papers in some international journals where people have certain specific and very special facilities where they do it. I'm not.
Yes, absolutely. What should be the spacing of core to another core? After taking core, what should be the perfect filler material?
You can go with any non-shrink free flow grout, sir, as far as the filler material is concerned.
Okay.
Any non-shrink free flow. For example, if I'm more familiar with Fosdal, it may be Convextra GP2 or GPI.
Spacing, sir, in between cores?
Sir, in between it again depends on the size of the column. The column is very huge. You take it about 1 meter or 2 meters. Here, the main problem is the designer would not like to take the course at the beam column joint or bottom or the top. He may always like to do it at the center. You can take it about half a meter or something away, so long as you don't cut the rebars. It's fine. And because anyway you're going to fill it up with a non-shrink free flow grout, which is nothing but M45 grade. So no, it should not be a problem. But don't take too many. No, don't take more than 2 or 3 cores per column. I don't even take 3 cores per column. I take hardly 1 or 2. That is enough. That gives you quite a good, feel about
how to assess fire damage using NDT.
Fire damage. Generally, the fire damage structures tend to carbonate. Okay, sir. Fire damage structures tend to carbonate. Carbonation is nothing but your phenolphthalein test or your pH value. So in any fire damage structure, we do UPV to understand whether due to any cracks have happened within the inside the column or the beam or the slab due to this fire. And for that you do UPV. If there is a damage, then if there is a UPV values are low, then we do low viscous epoxy resin grouting. Then we do a core test because we want to know whether due to the fire any reduction in the strength is there. By removing the core, we spraying the phenolphthalein solution. We know whether any carbonation has taken place because fire-affected structures tend to carbonate too. And third is we try to cut some reinforcement and then do a tension test on the rebars to understand any damage has happened to the rebars. These are the major 3 or 4 tests we do in any fire-affected structure. But be careful because it will go for insurance. Don't do it in the fire. Every part of the structure is fire damage, it's fine. If there are locations where the fire is minimal or where there is no fire, do in those locations also so that the insurance guy is very sure that only because of the fire this got affected because there are a lot of claims that are going to be made. As I told you, I learned it the bitter way because I took it only the first case about 15 years back. I took it only from the fire affected case. That guy came and took me apart. He said, how do you know that these defects could be pre-existing also? They might have done the concrete badly also.
What
So
is the
Yes,
sir? Next question. What is the indication that corrosion is taking place internally?
cracking. Because once the rods start corroding, they expand in diameter and they exert a pressure on the cover concrete. They initially there is a small crack. That time itself you should attend, but unfortunately it doesn't happen. You know, the corrosion, more bulging, then more wider cracks, more chloride going in, then spalling, then only people wake up.
Sir, how to estimate a percentage of corrosion resistance?
Percentage of corrosion is.
Yeah, so how to estimate the corrosion resistance of steel? The prior, construction itself.
Sir, see this Tata and all, many people are coming with the CRS rebar. Then PSL is coming out with the fusion bonded epoxy bar. These all have got corrosion resistance in a very broader perspective. For example, I do not know how to, for example, depassivation. Passive oxide film is there over a period of time. Then it slowly starts depassivating. Then it starts corroding. It's a reverse Z curve. Okay, sir. When you use a CRS bar, this horizontal line will go little for a few more years. You know, it will go further. But then once the depassivation takes place, even a CRS bar corrodes. They are not corrosion resistant. It is not like a stainless steel bar thing. Every rebar corrodes. But then it is how well you have made your concrete. If you have made your concrete perfectly well, then corrosion is not going to happen. Why corrosion is happening? Diffusion. Why your chloride and the carbon dioxide is diffusing? Your cover concrete is not made that well, or your covers are less. You're not given a proper cover. For example, severe exposure condition, 45 mm cover. You're not given that cover, then diffusion happens. So a CRS bar may take a little longer time to depassivate. That's all. But then it depassivates. So you can't say it is corrosion resistant. It delays it because of whatever this thing they are putting, it delays it. And for example, a fusion bonded epoxy bar, it delays it. But the problem with the fusion bonded epoxy bar is there is nothing wrong with the fusion bonded epoxy bar, but the way it is used in the site. We've gone to many sites where they dump the fusion bonded epoxy bar on the ground and the coating comes off. When the coating comes off, we call it as holidays. A small anode, a large cathode. Pitting corrosion takes place, corrosion becomes accelerated. So the manufacturer says, when you use a fusion bonded epoxy bar, when you are laying it in a slab or a thing, when there is, because of the transportation and handling, damage is there, they will coat it. But most of the time it doesn't happen. I mean, if there is a fusion bonded epoxy bar person in the thing, you'll get very angry with me for telling that. Even just before the lockdown, I was in a site where the fusion bonded epoxy bar was in tatters. It was laid on a deck slab where it was completely, the coating is not there. They say that they will coat it, but I'm sure they can't put their hand deep inside and then coat it. And there is nothing called corrosion resistant. You make your concrete properly, give proper cover as per the IS code, mild, moderate, severe, very severe exposure, make the concrete properly, you don't have any issue. You can put CRS bar, they're good because that, I told that Z curve. If it is this year, then CRS bar goes a little further away, few more years or few more this thing. Then you make the concrete badly, you can't expect the CRS bar to perform a magic. It also depassivates, but then it depassivates, takes a little longer time to depassivate.
Ideal method of repair for TG deck?
It's a concrete. So any repair methodology, what you use for a normal structure is there for a TG deck. Or suppose you are having any honeycomb, then you chip it open, then do a micro-concrete jacketing or do a polymer modified mortar depending on the thickness. If the thickness is only 20 mm, then you can't do a micro-concrete jacketing. Go with a polymer modified mortar. If the thickness is more than 40 mm, then you cut it into a regular pattern and then do a micro-concrete jacketing. That's it. There is TG deck means nothing great about it. It's again like a beam or a, because you're doing with concrete only. Only thing is done with the temperature control. That's all.
Which type of coating is suitable for offshore RCC structures?
Any silane siloxane. If you look into fast rock, it's called R²S or something. And nowadays, there is some MCU coating also is coming into play, but then it's expensive. Silane coatings maybe 500 rupees per square meter, whereas MCU coating maybe around 1,200 rupees. Silane siloxane is more than sufficient. And then suppose it is Bangalore or Hyderabad, where there is no chloride, then you can go with the anti-carbonation coating, which is much cheaper. There are companies which sell anti-carbonation coatings. That's what I said. Look at the scenario. If it is due to chlorides, go with the silane coating. If it is only Bangalore, Hyderabad, or Bhopal, or Delhi, or something where corrosion takes place due to only carbonation, go with the anti-carbonation coating. Anti-carbonation coatings are generally cheaper, but they say the silane coatings can also take care of anti-carbonation. I'm not too deep into that. So just.
Sir, what is meant by micro-concrete?
Micro concrete is nothing but your self-compacting concrete. And because in a repair scenario, you are looking at jacketing of 40 mm or 50 mm thickness. The 40 mm, 50 mm thickness, you cannot go with a regular concrete, like, M30 or M40 or M20. Because, it's very difficult to push it into that 40 mm, thickness. So we can go for a self-compacting concrete. We can definitely go for a self-compacting concrete, but it is site-made. So there is a possibility that mistakes could happen. So they are going for a micro concrete, which comes in 25 kgs bag, and they are giving very clear, I think 0.18 or 19 is a water cement ratio. So you take 25 kgs, 25 into 0.19, so much of water is added. Then you take this thing, put it in a thing, and then mix it. I mean, it depends on the volume. So, and then pour it, because it comes pre-mixed with the super plasticizer, because it's a free flow. Like, you don't have to worry much. Just put that water cement ratio. It is like a self-compacting concrete, and you can add 50% aggregate also if the volumes are more. So just take it and pour it in. So if you put a self-compacting concrete, already you made a mess with the regular concrete. So you're going for rehabilitation. If you are very strong, if the site is strong, the contractor is strong, he's confident that he can do self-compacting. He can go, because self-compacting concrete will be 6,000, 7,000, 8,000 rupees per cubic meter. Micro concrete is for 45,000, 50,000 rupees per cubic meter. Yes. Again, as a consultant, it is, you can say self-compacting concrete is fine, but then if they don't put the self-compacting concrete, they'll again come back. They'll mess it up. So you generally try to give micro concrete, which their possibility of messing it up is less. That's all.
Sir, what type of tests have to be conducted to assess the rehabilitated work? And is there any caudal provisions?
No, sir. There is no caudal provision, sir. And in most of the cases of my 35 years experience, very rarely the client has asked you to come and do a post-repair evaluation. The post-repair evaluation could be only UPV, sir, because you are always jacketing or doing it with a polymer modified mortar. So you do a UPV, then if the integrity is good, then you know that the repair has been carried out effectively. Very rarely we go and do. In some of the silos for cement plants we have done, sir. Otherwise, for normal, whatever I have shown you, that for 4 crores or 50 lakhs or 60 lakhs, they just do the job and move on. They don't want somebody to, initially they'll pay the 2 lakhs or 3 lakhs for the assessment. And then after spending 50 lakhs, they will not like to spend even 50,000 rupees for assessing the efficiency of the rehabilitation.
How to ascertain durability of the rehabilitated work?
The durability of the rehabilitation. Because you are anyway chipping, removing the unsound concrete, coating the rebar with the zinc coating, or removing the rebar and then putting a fresh rebar. Probably you can put a self-regulating anode or something, but it's quite expensive. You put a self-regulating anode and put a monitoring box, definitely you can monitor it through half-cell potential every 6 months, which my partner is doing for the Chennai Port Trust. He has repaired a jetty where he had put self-regulating anode. Every year they go and take a half-cell potential and check it. Half-cell potential, nothing but durability. You can do it, but expensive. See, that's a problem. How far the client is willing to go. That's the thing. You can give anything, but then the client has to agree. Yeah, because he has to work with a certain budget. We can.
What are intrusive tests?
Intrusive. Core drilling is an intrusive test. Because UPV and all, you're not breaking open anything. Here, core test, you're cutting, and then half cell potential also, you're chipping open the cover concrete, exposing the rebar. Maybe you can call it an intrusive test. That's it.
Sir, which method of NDT requires leak proofing of casting before inspection?
Don't understand, sir. I don't understand the question. Which method of NDT is it?
Requires leak proofing of casting before inspection.
I have no idea, sir. This is something to do with some other branch of engineering, sir. We don't do that such things, sir. Maybe it is some NDT which is being, I don't know, some mechanical thing or something. I'm not very sure.
Yeah, here is a question from participant Hasib. Hasib, you can go ahead.
Hello, good afternoon. Thank you for a nice lecture. You are able to hear me, please?
Yes.
Yeah. There were good case studies. This is related to the durability question, but a little bit extension to that, because the client is spending so much crores of rupees in rehabilitation and repairs and all of it. So normally they will expect extended life of the structure. So that's the similar question of durability. How you estimate the extension of life of the structure after the repairs and also the pre-repairs, like when you're doing the condition assessment, we need to know what is the life expectancy or how much the life expected in that. So how do you do that?
I'll answer it in two parts. One is, why people are not post-repair evaluation. You're not spending 40-50 lakhs. Why people don't want to come to you again for a checking the efficiency most of the time is most of the repairs are done by special contractors and construction chemical companies. Like the owner or the PMC, they decide they're going to go with this particular construction chemical company, Fosrock or BASF or Sika or so on. I mean, so many things are there. Now, each construction company has certain applicator. So the job is given to an applicator. And the applicator invariably gives a, what is it called? A guarantee, 5 years or something for the repair. And now I do not know. Olden times, the construction chemical company also used to give a guarantee for their products. So that is one of the reasons why the owner, after spending so much of money, when he is getting a guarantee from the applicator, but whether that guarantee is reliable and all that, I don't know. But he gets a guarantee on paper from the applicator. Before it was from the construction chemical company also, because they were supplying the material. Now I do not know whether to the best of my knowledge, no construction chemical company doesn't give, only the applicator gives. So they get some kind of a guarantee. That is one. Your second question is, what is the thing you said? Second part?
Service life expected, like expected service life.
See, there are models you have this Life 365. You're a faculty means you'll know that there are Life 365 model and this model, that model. There are so many models are there. Even for this, some of the projects, like for example, all the metros have a lifespan of, the service life is supposed to be 120 years, correct? And to achieve that 120 years, how did they know the construction has happened? How do they need 120 years? So they bring in specification. They say the RCPT number should be 800 or 1200 at end of 28 days or 56 days. The permeability should be this much. They're bringing in some kind of a specification, because all these diffusion coefficient and this thing are fed into these Life 365 model or any model. So whatever you feed in, it gives certain number. So that's the only way you can find out the life extension. But personally, I'm not very confident about all these models, because whatever you feed in, it spits out some numbers. But what numbers we are giving and that models, how safe they are, or I just don't know. And if you don't mistake me, whatever numbers I'm going to give, it is going to stay there for 80 years or something. As a consultant, I'm giving. I'm going to go away another 15 years time. So how far I'm right or I'm confident in giving those numbers is something I don't know. You may have to talk to somebody like Dr. Manu Santanam at IIT Madras, because they are doing a lot of these life prediction models. But how confident they are and how enthusiastic they are about all these things, I don't know. Because I've done it with, I run an IT Madras incubator company with him. He's a very knowledgeable person. Probably you can just write a mail to him, ask him how confident they are that they are doing models, because these models mostly depend on the diffusion coefficient, so many other factors. Again, these are all concrete parameters, what is being fed into these models, and it gives. And as I asked you, Metro, 120 years. So what are the factors that they took in the specification that it will stay for 120 years? To the best of my knowledge, chloride diffusion, water permeability. These are the two things they have considered.
Yeah. Actually, I'm not a faculty, but I'm from the field. We are also consultant, and I know Manu Santanan, and we have been working with him on certain thermal modeling and other issues. Yeah. So basically, this prediction models or the life extension of service life, like these Metro 120 years service life requirement. Normally in field, people are just means they are not. Means there is no much of difference in the way of working for 30 years life structure and 120 years. So in theory, okay, you're talking about it, but means to verify and to make sure that really it is going to last for 120 years or 100 years is a big task. So a lot of things, a lot of testing, like you're talking about the chloride diffusion models and that NTP 492, NTB 492 and other tests which are to be incorporated. Otherwise, this 120 years is always just on records. Means they are just telling, yeah, okay, it's last going to.
One more thing I'm very happy with the Metro specification is, at the time of the specification itself, they said the concrete shall have a workability retention of 3 hours, which forced the contractors to go for a PCE-based admixture. To me, in this past 10 years, I've been a research scientist 25 years. I didn't know what was happening in the industry much. Okay, I was going here and there. I was going quite extensively, but still, this past 10 years has opened my eyes that the only thing that screws up the service life of the structure is the workability retention of the concrete. These guys, unfortunate that once the cubes pass, everything is taken for granted. And I find in most of the sites, they are even sir, about 2 days back, me and Manu were discussing 118 water, sir. 118 water with the mid PCE, they are making a precast girder. And they are showing me a workability of 190 mm. I don't want to go too deep into this. Like that, everywhere I go, when the course failed, the people are so angry with me. I don't know what to do. Sometimes I feel very dejected. And I ask them the design mix, they are using 155 water, and then they are using an SNF or a very low-end mid PCE. Obviously, water is being added. Because it cannot hold the retention for more than 1.5 hours or something, and they're placing the concrete after 2 hours and 2.5 hours, and water is invariably being added. And then the cubes are getting passed, and then due to some controversy, course are taken, course fail, and they get angry with us for failing the course. And when you and you feel so bad, so you don't want to prove that I'm always right. So you ask for the design mix, you discuss with them on the design mix. Sir, how did you do this concrete with 155 water or 158 water with a very low end mid PCE? No answer, but they keep blaming you for giving them a very negative core result. This has been my problem it is rising more and more. For example, I'll tell you, sir, I'll share an example. Probably I could have even put that PowerPoint because this is a different, forum. There was a bridge in Chennai where the pre-stress girder, precast, post-tension, it was M50 grade concrete, and they got the cube results properly at the end of 7 days. They pulled the whole end block came off. The whole end block came off. Then they were blaming the IIT professor, your design mix was wrong. I go to the site, first thing I ask her, where is the design mix? Because this is, I've seen in many sites, design mix, 140 water SNF. I said, with 140 water, how did you make this concrete? It'll be so hard. You can't make it. They were fighting. I got it correct. I got it right. But fortunately, in that site, somebody came and took the course. It should have been. It's an NHAA project, M50. The target strength should have been 63. Water cement ratio was perfect, 0.31. But they wanted to cut down on the cement, 450. I said, MHA mode specification, 540 you can go. Why did you bring it to 450? That's made your water 140 and you are using an SNF. They were fighting. Luckily, they took a core after almost 28 days. Actually, it should have been 50 MPa. 80% is 40 MPa when they stressed it. They took a core after 28 days, it was 28 to 30 MPa, which means that it would have been only 20 MPa when they were pulling it. En bloc comes off. And they keep fighting. They keep fighting with you for pointing out such things. So your question, very pertinent question, service life. We are more bothered about diffusion, and we are more bothered about this. We are more bothered about that. Here we are missing out on a very simple factor of the workability retention, because every site is different, every scenario is different, and if a proper admixture is not used, the workability retention is not maintained. They are invariably, passing, because the first thing the transit mixer comes to the site, the QC boys, you'll find them running like mad and taking those cubes. In most cases, it is done properly, but in many cases, it is not done properly, because they are negotiating for the cost, and then unnecessarily putting the wrong admixture for the wrong water content, and problems crop up. And we are talking so much about service life, diffusion, this, that. And that way, I was very happy with the metros when they said 120 years, they brought in a 3-hour retention also. But ultimately, they diluted it in Chennai. I don't want to go into it. They diluted it in Chennai because it's initially started with the full PC and ended up with a mid PC. So these things are happening. And, we are spending money. We are spending so much of money. And what is this admixture in the overall cost of a project? There is nothing. Why people go and make a big issue out of it? That's what I'm at a loss to understand for this past 5-7 years. And people don't like if you go into those areas, because passing cubes is fine. I'm not telling everywhere they are fudging the cube results. Yes, cubes are passing on their own. But sometimes why this is happening? Why you are keeping the concrete for 3 hours, 4 hours, and then pouring it? You find 6 transit mixers standing in the site, 4 transit mixers standing in the site. What is the workability retention? I don't know. These are issues. And as far as the life prediction model is concerned, already you are in touch with Dr. Manu. I have a lot of respect for him. You can see, because I'm not the right person to talk on because I have not done a life prediction model. But I have given him data for life prediction model. But he should be the person who should be. If he's confident, then it's fine. Sir, I don't know whether I have answered your question properly or improperly, or I have gone around the thing, because this is something which I wanted, because you are coming from the field. This is something, bridges.
No, yeah, you are very true. Actually, in the field, basically, people are still, unfortunately, people are still focused on strength part of it. They are just thinking about testing of concrete, and if strength is okay, then everything is okay. But durability parameters are really missed. Maybe secondary cementitious materials and the testing specialist testings for durability and water cementation and all those things. That's important actually.
For your information,
to have our own in-house prediction model, by diffusion model.
Yeah.
No, I am from Jacobs.
Oh, Jacobs. Okay, you're a consultant, sir. I should not be sharing this. Some of the contractors, when the core fails, they are going to the extent of bringing a cube and asking us to take a core from the cube and testing it in front of the client. I said, well, this is just not on.
Yes, unfortunate.
Which is in, I don't want to name the place, we tested and all the cores failed. I mean, failed marginally, but not in a big way. But then, it creates so much of problem for the government. And nobody is happy, including the government, they are not happy that, cores are failing. That's today's present mindset is that, sir. Very unfortunate.
Unfortunate, actually. Sorry, I have another call. Actually, it's already started. Then they're pinging me. 12:30 was to start. So I'll take leave, please, if you don't mind. Thank you.
Sir, Ishwar Reddy, sir, any more questions? Sir?
Yeah, no other questions, sir. So almost we have answered all questions.
Okay, sir. Thank you.
So thank you very much, sir, for your valuable lecture and experienced case studies.
Okay.
So it will give a lot of takeaways for all the participants. So I request you to put in the form of a book. It will be highly helpful, your experiences. You take help from the somebody, then please do write a book.
Thank you, sir. Thank you so
Thank
much.
you. Thank you so much, sir.
Thank you, and Yuvraj, for inviting me, giving me an opportunity to speak to all of you. Thank you, sir.
Yeah, sir. Thank you. Thank you so much, sir. Bye, sir.
Bye, sir.